Chapter 7 is applications of integration, and we start by looking at area under the curve, but instead of one curve, we're looking at the area of a region between two curves. So if we have a graph and we have a curve, I'm going to use some colors here. I can find the area underneath this curve between A and B, right? And we know this to be true because it's what we've been doing for a little while now. And that's denoted by the integration from A to B, and we'll just call this f of x dx. So we're really looking at all of this area. Now, what if I want to look at the area in between these two curves? So I'm just looking at this portion. And let's just call this G. Well, what I know what to do is find the area from A to B of G of x. And that's going to give me all of this underneath G. So is there a way, just by all this crazy shading, you can think, let's think, let me make a think cloud. Think dot 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 dot, a way to find the area between F and G. I know you're so smart. You guys can figure this out. Yes. I'm going to find the area in between F and G by subtracting the two areas, and it looks like this. This in turn will just give me all of this area. Now it's all gray. I take the area from F, subtract out the area underneath G, and this is what's left over. Alright, so let's see this in action. Here's a problem. Find the area of the region bounded by F and G. And what's given are the two functions. So you know I'm a visual, so let's draw what these might look like. So f of x looks like it's a cubic and it's shifted 1 unit to the right. So I am just going to do a rough sketch here. Then I'm going, so that's f. I'm going to graph g of x, which is x minus 1. And so that's going to look a little bit like this. That's a terrible picture. I actually have area here, and then there's a little area there. So if you're like me, not the best drawer, then how am I going to do this analytically? And of course there's a way to do this analytically that's going to make perfect sense. So I want to look to see the area bounded by these two graphs. So let's see where they intersect each other. Those are going to be pivotal points. So x minus 1 cubed equals x minus 1. This is for intersection points. Alright, so we're going to cube root both sides. don't know, does that do anything for me? Looks like I'm going to have... No. Here's a typical problem. Find the area of the region bounded by the graphs of f and g. So, let's draw a picture. X squared plus 2x plus 1. So I'm going to just do a rough sketch, because I already know what this looks like. This is actually number 2 on page 452, but we're actually going to find the area. So there's my parabola, x squared plus 2x plus 1, and g of x, which is 2x plus 5, looks something like this. So I'm actually finding the area bounded by these two curves, and that area is here. So what's important is my intervals, A and B, right? So I need to know those points when I set up my integral, A to B. So I need to know those points. And now what am I going to do? I'm subtracting these two. So it's important to see that the linear function is above the parabola, the quadratic function. So it should make sense for us to set this up g of x minus f of x. And if we did it the other way, what do you think would happen? Something to think about. Alright, so I'll leave you with that open-ended question. Let's figure out the values of a and b. Well, in order to figure a and b, those are the points of intersection. So I am going to find where these two graphs, these two functions intersect. X squared plus 2x plus 1 equals 2x plus 5. So this is for intersection points. So what happens? I subtract 2x from both sides. I add 1 to both sides, and I get x squared. Subtract 1, equals 4. X equals plus or minus 2. So my a value, negative 2. My b value is positive 2. So what does this look like if I'm to set this up? The integral from negative 2 to 2 of g of x, 2x plus 5 minus x squared plus 2x plus 1 dx. So now from here it should be all downhill. So I'm going to combine like terms. 2x minus 2x is 0. 5 minus x squared minus 1. So I'm looking at the integrand simplified to be 4 minus x squared. And that's a pretty simple integral. You can certainly do this by hand. 4x minus x cubed over 3 from negative 2 to 2. And so I have 8 minus 8/3 minus negative 8 plus, because it's a negative 2 cubed, which is going to be a negative 8 times a negative in front, 8/3. 24/3 minus 8/3 is 16/3 minus negative 24/3 plus 8/3 is a negative 16/3, so we'll change that. Final answer, 32/3.